Section 4.8, Trig Applications and Models, is going to be our last section for Chapter 4B. So let's go ahead and jump right in. So this is your first example from your notes. You can go ahead and read it yourself. What we're going to do is I'm going to start drawing a picture for this. So the first thing I see is that it's going to be heading due north. That is going to be the first thing that I focus on. So I want to draw a picture where it actually shows due north. All right, so due north. Oh, got some errant marks here today. All right, so we want to head due north, and then we're going to go northeast. So I'm going to make sure that I have enough room in my picture to do that. So we'll go due north. From the port of departure, so down here at the bottom, we're going to call this the port. And it's going to travel along this path at 35 knots, and from noon to 4 is going to be 4 hours. So I'm going to take that 35 knots and times it by 4, and that's going to give me this due north distance, which is going to be 140 nautical miles. Then from here, our ship is going to change direction. So let's draw a little compass up here again. This time it's going to be going northeast. All right, so from that location, I'm going to go to the northeast. And then the bearing, again, comes from north towards the east, so that angle in there is going to be that 42 degrees that was given to us. Then it says that it's going to be 3 more hours at that 24 knots. So this distance up here, if I take 24 times 3, gives me 72. Now, my boat is right here at the end of this location. So my job is to figure out the distance from the port of departure. So that I'm going to call x. And then I want to be able to find the bearing as well, and we'll get to that in just a second. So the first thing that I need to do is I need to find the angle inside the triangle. Right now I have an angle outside the triangle at 42. Well, remember that from north to south, that is going to create 180 degrees. 42 degrees is already taken. So to find this measurement in here, which we're going to use, I'm going to do 180 minus 42, which is going to give me 138. And I'm going to use that 138 because that angle's inside the triangle. Now, if you take a look at this, we actually have law of cosines. So let's just go ahead and plug it in. So I'm looking for x, which means I'm going to do x squared is equal to the 2 legs squared added together minus 2 times 72 times 140 times cosine of the angle opposite x, and opposite x is that 138 degrees that we just found a second ago. Take a second and type this in, and it looks like the x that we should get is going to be approximately 199.4136 nautical miles. This is our distance from the port of departure. So that's how long x is. Now I'm definitely going to be using this again, so I stored this as x in my calculator. Again, drawing my little button off to the side so I remember. Now I go back to the port. I want to take a look at the actual path of the boat. So if I were to take a look at the path of the boat in purple, it's that line. So starting from either due north or due south to get to that line, and it has to be an acute path. So if I take a look back at my port, the only way from due north or due south that's going to be acute is right there. So I'm going to call that theta. That's what I'm looking for. Take a look at the picture. Looks like theta is inside the triangle. Awesome. So I'm going to go ahead and just do law of cosines again. So I'm going to use the 72 squared equals this time. So I'm going to pause, go ahead and fill this in. I would pause if I were you too and see if we match. Okay, so after filling in my values, I got that theta was equal to 13.9807 degrees, so a tiny little angle. But that's not the bearing. The bearing has to have direction in it as well. So we have the angle. Now we just need to know if it's coming from north or if it's coming from south. So if I take a look back here at my picture, this angle is going to be starting from north and heading towards the east. So when I write my bearing, I actually have the north first, then the degree traveled, and what direction it was going towards, which is east. And there's our first example. Okay, number 2. Basically going to do the exact same thing, so I'd go ahead and read the question to yourself, and we're just going to start drawing the picture. So it looks like we're going to go due west. So if we want to go due west, and then from there we're going to go northwest. All right, I need some space off to the left here. So if this is my port, I'm going towards the west, then I change direction and end up heading northwest. So from the north towards the west. Oh, it's up a little high. All right. Now, I'm going to make sure that we connect the end back to the port itself. All right, now let's fill in some measurements here. So the first thing that it says is going to leave at 10 and go due west at 20 knots for 2 hours because until noon. So that means that this distance across the bottom is actually going to be 40 nautical miles. Then it gives me the change of course at north 54 west. Okay, so from the north towards the west, that is going to be the 54 degrees. So let's go ahead and put that in there. Then, let's see, find ship's bearing and distance from port of departure at 3 p.m. Okay, so now from noon to 3, doesn't say that the ship has changed speed, so we assume still the same speed at 60, or at 20, so then 20 times 3. And remember that our boat is up here. All right, so I want to find how far the boat is from the port, so there's my x. And in this case, I look back at the picture, and 54 degrees is part of one of the angles inside the triangle, but not the whole thing. So I remember going from north to east is going to be 90 degrees. So the entire angle in there is going to be 90 plus 54, which is 144 degrees. All right, so I can go ahead and set up my law of cosines. So I would pause now if I were you. I'm going to go ahead and set it up, and then pause and see if we match. Okay, so I went ahead and set up my law of cosines, plugged in the information that I know, and it looks to me like the distance from the port of departure is about 95 nautical miles. I again know I'm going to be using this, so I would store it somewhere, so probably store it as x, and then I'm going to go ahead and find that angle from the port. All right, so going back to where the port is and taking a look at that line segment of where the ship is actually on. So I know that this blue line is the actual path of my boat. Now what I want to do is I want to find the angle inside the triangle that goes back to the port. So I would look for this angle here. Now that doesn't necessarily mean that it's going to be the bearing, it's just inside the triangle by the port. And based off of the information that I have, I think the easiest way to do this is to find that angle. So let's go ahead and find theta, use law of cosines again. I'm going to go ahead and pause and then see if we match. Okay, so going through and doing my calculations, I got that theta was 21.7180 degrees. Now I take a look back. This is not going to be the bearing because it is an acute angle, which is great, but it doesn't start from due north or due south. So what I want to do is I want to find the angle that is actually right next to it, starting from north going towards, looks like the west this time. I'm going to call this angle alpha. Well, I can find alpha because alpha and theta are complementary, so I can do 90 minus theta. So when I did that, I am going to get 68.2819 degrees. Now, to do the bearing, I'm going to take a look at this. It's still going to start from due north, and it's going to go towards the west. So there's the bearing and the bearing and the distance from the port of departure for the second example. Okay, moving on to example number 3. So I'm just going to go do the exact same thing and just start drawing my picture. So it looks like it's going to go due west, and then from there it's going to go northeast. All right, so it looks like it might be turning back on itself. All right, so due west. And let's say that this down here is the port. And then from there, it's going to go northeast. All right, I think I want to figure out the measurements here first, though, just to see how long this thing is going to be. So 42 knots for 6 hours. So if I do 6 times 42, that gives me 252. That's going to be this distance down here on the bottom. Then from there, I want to go northeast, and it's going to be 31 knots for another 5 hours. So that's going to give me 155. So not quite as long as this one. So I want a line segment that's not quite as long, but I do want to show that change in direction. So probably around there. Just make sure that it's definitely shorter. I want to have a fairly accurate picture here. All right, so need to put in my 33 degrees here. So it went north 33 east. So there's the 33 degrees. Then this line segment is going to be 31 times 5, which is 155. So let's go ahead and put that in here. And then my boat is going to be, or my ship is, the ship is going to be at the very end here. All right, so we want to connect its current location back to the port of departure, and that's going to be X. So I'm going to do the exact same thing that I would have done before. Actually, I did do previously. I want to find the angle inside the triangle. Notice that the 33 is on the outside. So to find this angle in the corner, right here, I'm going to go ahead and do 90 minus 33, which is going to give me 57. So that means that this angle is 57 degrees. All right, now that I know that, I can go ahead and set up my law of cosine. So I'm going to go ahead and pause, see if we match. Okay, so I ended up with a distance of about 212 nautical miles. All right, now the next thing that I need to do is be able to find the angle back at the port. Okay, so go back to the line segment where the actual boat path is located. So right here. I want to go back to the port. The only angle that I can, well, no, that's not true. The easiest angle for me to find right now is probably that angle inside. So I'm going to go ahead and call that theta. That's theta. And go ahead and do law of cosines again. Okay, so that theta angle I got to be just shy of 38 degrees. But again, when I want to find my bearing, I have to go back to the port of departure. It needs to be an acute angle, and it has to come from due north or due south. If I take a look at this, the only way for me to get that acute angle path would be from due north. So that is the angle that I need. Likewise, I find it the same way that I did before. So I know that alpha is just going to be complementary with theta. So if I subtract those, that's going to give me that angle on the outside, which I believe is 52.1989. Now, remember, for bearing, you still have to put in the actual direction. So taking a look back at the picture, it's going to start from north, and it's going to travel 52.1989 degrees towards the west. Okay, and that's example number 3. Moving on to our last one. So last example, I am going to go ahead and pause it and draw my picture. I highly recommend that you stop the video right now, see if you can draw the picture, and then see if you and I match. Okay, hopefully our pictures match. So I went through, filled in all of the information. I even color-coded the X so we see where the boat is. All right, now we need to find some angle inside, preferably opposite the X. So one of the things that I want to remind you of back from geometry, a million years ago, are parallel lines. Whenever you have a line segment that represents north and south, and another line segment that also represents north and south, those two are going to be parallel to each other. If we take a look at the other line segment that actually connects those two, which is the original 140, that's going to create, well, back in geometry it was called a transversal. So if I take a look at the purple vertical lines that are now parallel to each other and the orange line that is the transversal that goes in between them, what we have is alternate interior angles, which means the 51 degrees up in the corner here has to be identical to this angle here as well. So because of alternate interior angles, that both of those pink colored ones are going to be 51 degrees, which means I can now find the angle that's inside the triangle up by the 31. If 31 is already taken, then the angle in here is going to have to be 20 because I want a total of 51. Now I can do law of cosines with the 20 because it's inside the triangle. So go ahead and pause, see if we match. Okay, so I ended up with a distance of about 49 nautical miles, give or take a little bit, which makes sense because if I traveled 140 in one direction and almost completely doubled back on myself, then yeah, I'm going to be relatively close to the port of departure in the first place. Okay, so now what we need to do is we need to be able to find the angle inside the triangle close to the port. So I go back to the port, and I think the angle inside the triangle close to the port is going to be this angle. So that's going to be my theta. So I'm going to go ahead and solve for theta. Again, pause, see if we match. Okay, so for the angle inside, I ended up at 84.0050. Now, taking a look back at the picture, this is one of the things that can be a little difficult with this. You have to determine if, based off of the angle and the angle that was given to you, is this really an acute path from the north or the south? Well, if you take a look at the picture, even if a picture wasn't drawn 100% accurately, and let's say the 143.5 line segment was a little bit shorter than the 140, based off of the 51 degrees that you already had from due north and the theta that you just found, which was 84 degrees, those two totaled together are going to be well past the 90 degrees that would be at due east. By adding the 84 and the 51, I realized that we're going to get a fairly large angle, obtuse actually. So much so that I know from due north is not going to be the bearing. What I need to do is I need to find the angle on the outside now. So it is this angle down here that is going to represent the bearing from the port of departure. Remember, it has to be acute, and it has to come from due north or due south. So in this case, to find alpha, I know that the 51 that was given to me plus the theta I just found plus the alpha takes me from due north to due south, which I know is 180 degrees. So if I go ahead and solve this for alpha, plugging in what I know, I'm going to get 44.9949 degrees. Okay, again, looking back at the picture, this does not start from due north, it starts from due south. So I'm going to be going from the south, that angle towards the green line, which is going to be towards the east. So my bearing is going to be south, 44.9949 degrees towards the east. And that concludes all of our notes for Chapter 4B.